Hey guys, in this video we're going to be talking about solving quadratics using the square root method. So we're going to have some problems that are just procedure and some problems that are in context. So let's take a look. All right, solving using the square root method is actually pretty simple. So the first thing we want to do is isolate the x squared by using inverse operations. So it's just like solving an equation, except you're getting an x squared by itself instead of getting an x by itself. Okay, once you've done that, you want to take the square root of both sides. If we're dealing with a procedure problem, that means there's no context. You are to write your answer in simplified radical form as necessary. So if it's not a perfect square, you have to simplify the radical. If it's a context problem, it doesn't make sense to write your answer like that. So you can go ahead and use your calculator and round your answer to the nearest hundredth if necessary. Okay, so let's take a look. First problem here is very simple. It's x squared equals 16. Notice that there's no coefficient in front of x squared and nothing being added or subtracted at the end. This means x squared is already isolated. So we can go ahead and take the square root of both sides. So the square root of x squared, as we learned before, you divide the exponent by 2. 2 divided by 2 is 1. So I'm just left with x equals. The square root of 16 is 4, but you have to remember it's actually positive 4 or negative 4, because if I do negative 4 times negative 4, I still get 16. So in math, we use this little symbol. It means plus or minus, and then it is 4, because the square root of 16 is 4. And that's it. That would be your answer for this problem. Now, they're not all that simple, so let's take a look at what to do when they're not that simple. All right, so for this problem, there's still no coefficient of x squared, but we do have a minus 24 at the end. So we need to move this over to the other side. And we're going to do that by adding the 24, that's the inverse operation, oops, not 27, 24, over to the other side. So now I have x squared equals 24. So the x squared is isolated. I'm going to go ahead and take the square root of both sides. I'm going to get x equals, I still get plus or minus. However, this time 24 is not a perfect square. So we're going to have to simplify the square root of 24. I'll write it like that for now, but we're going to find all of the factors of 24 so that we can simplify it. We already know that 24 is not a perfect square, so 1 in 24 does nothing for us. It is divisible by 2. 2 times 12 gives us 24, but that's not a perfect square. It's divisible by 3 times 8, which is not a perfect square. It's divisible by 4, which is 4 times 6. Now 4 is a perfect square, and the only number left to check is 5, which 24 is not divisible by. So these are the factors I'm going to use. So now we have x equals plus or minus the square root of 4 times the square root of 6. The square root of 4 is 2. So we're left with x equals plus or minus 2 root 6. And that would be our final answer. Let's try another. This time we have a problem that has both a coefficient and a constant at the end. So we're going to have to get rid of both. So think about this as if it had been negative 2x plus 120 is negative 30. You attack the constant first. So the opposite operation is to subtract 120 from both sides. So now I have negative 2x squared equals negative 150. I'm going to divide both sides by negative 2. And I'm going to get x squared equals negative, or not negative, sorry. So x squared is negative divided by negative is positive 75. So now that the x squared is isolated, I can take the square root of both sides, leaving me with x equals plus or minus 75 is not a perfect square. So we're going to have to do a little more work. All right, so let's find the factors of 75. So we have 1 and 75. 75 is not divisible by 2. It is, however, divisible by 3. It's 3 times 25, and there's our perfect square. So now I have x equals plus or minus the square root of 3 times the square root of 25. Square root of 25 is 5, so I have x equals plus or minus 5 root 3. And that would be our answer. Okay. Let's try some practice problems of those. We have 4 of them. All right. Number 1. We have x squared equals 169. Now 169 is a perfect square, so if I'm just going to take the square root of both sides, I'm going to get x equals plus or minus 13. Done. All right, number 2, we have x squared minus 18 equals 0. This time we have to get rid of the constant, so I'm going to add it to both sides. And then we have x squared equals 18. X squared is isolated, so let's take the square to both sides. This time we have a radical that is not a perfect square. So I have x equals plus or minus the square root of 18, and we're going to have to find the factors of 18. So 1 and 18 does nothing for us. 2 times 9, however, is great because 9 is a perfect square. So now I have x equals plus or minus square root 2, square root 9. Square root of 9 is 3, so I get x equals plus or minus 3 root 2. All done. All right, let's try number 3. Okay, so 3 has 9x squared plus 30 equals 57. So the first thing we're going to do is subtract 30, which gives us 9x squared equals 27. Divide both sides by 9. We're going to get x squared equals 3. I can then take the square root of both sides, and I get x equals plus or minus the square root of 3. Now 3 is not a perfect square, but it also only has 2 factors, 1 and 3. So that is as simplified as it's going to get, so we are done. All right, one more problem. Number 4, we have 3x squared plus 6 equals 87. Subtract 6 from both sides. We get 3x squared equals 81. Then we're going to divide 81 by 3, and we're going to get 27. So x squared equals 27. And I'm going to continue this on up here. I'm going to take the square root of both sides to get x equals plus or minus the square root of 27. 27 is not a perfect square, so we have to find its factors. I'm going to write that over here. So we have 1 and 27. It's not divisible by 2, but it is divisible by 3. It's 9 times 3, so that's the factor we're going to use. So now we have x equals plus or minus the square root of 3 times the square root of 9. The square root of 9 is 3, so we have plus or minus 3 root 3. And that's our answer. All right, let's take a look at how this works in the real world. All right, so the function f of x equals negative 16x squared plus 576 represents the height in feet of a free-falling water balloon x seconds after it was dropped from a hot air balloon for some reason. After how many seconds does the water balloon hit the ground? Okay, so we're working with this function here. F of x equals negative 16x squared plus 576. Now, if you recall, the ground level of any of the functions that we've been working with, any of the quadratics, has been the x-axis. And that is when y is 0. And remember, f of x is just a fancy way to say y. So we have 0 there then. I want to be at a height of 0. So 0 equals negative 16x squared plus 576. And now we're going to solve this just like all of the other square root problems. The first thing I'm going to do is subtract 576. So I have negative 576 equals negative 16x squared. Divide both sides by negative 16. 576 divided by 16 is 36. So I have 36 equals x squared, which now allows me to take the square root of both sides. And the square root of 36 is both positive and negative 6. But remember, x represents time here, and it doesn't make sense to have negative time, so the only answer we keep is the positive 6, and it is 6 seconds. So that's how long it would take the water balloon to reach the ground. Let's try another. All right, so the function f of x equals 4x squared minus 196 represents the depth, which is x f of x in feet of a scuba diver x seconds after starting to swim towards the surface. All right, so we got to find our two solutions here. So the surface level in this case is 0. So we're still doing 0 equals 4x squared minus 196. So I'm going to add 196 to both sides. And I get 196 equals 4x squared. Divide both sides by 4. 196 divided by 4 is 49. So we have 49 equals x squared. So I'm going to square root both sides, and I get x equals plus or minus 7. Okay, so those are your two solutions. So for number 1, the two solutions are going to represent when the diver is at the surface. So we have to think about that. So two solutions represent or rep when the diver is at the surface of the water. Okay. Now the negative 196 is the starting depth of the diver. In other words, the diver started 196 feet below sea level, or below the surface of the water. All right, how long did it take the diver to reach the surface? Now remember, the diver started at negative, so if this is the surface of the water, she's starting down here. So that's at negative 196 feet, okay? So they wanna know how long does it take her to go from here back up to the surface of the water, okay? That's 7 seconds, okay? So that would be the answer for number 3. But her entire dive includes the time it took for her to get down here in the first place, which is where that negative 7 seconds comes in. But really, it's still gonna take her 7 seconds to get down there, which is the same amount of time it takes her to get back up. So that means her entire dive is 14 seconds. And that's it for that problem. Let's try a couple more. All right. Rory drops a stone from the top of a cliff. The base of the cliff meets a body of water. The stone's height, f of x, in feet, x seconds after it is dropped, can be represented by the function f of x equals negative 16x squared plus 40. All right, number 1, what does the 40 represent in this scenario? Well, the 40 represents the starting height of the stone. So, excuse me, the stone started 40 feet above the water. Okay. And number 2, how long will it take for the stone to reach the water below? So we have 0 equals negative 16x squared plus 40. Subtract 40 on both sides. So we have negative 40 is negative 16x squared. Divide both sides by negative 16. That's going to give us 2.5. So 2.5 is x squared. Take the square root of both sides. And we get 1.58 rounded approximately. So x is 1.58 seconds. And again, we don't care about the negative time because that doesn't make sense in this problem. Okay, one more. An icicle drops from the top of a 32-foot tall tower. Write a function that represents the time it takes for the icicle to reach the sidewalk below. So if you were paying close attention, you should know that it's always f of x equals. And we're dealing with feet here, and typically feet has a negative 16x at the beginning. And then you're always adding on the starting value, which is 32. All right, so then for part 2, to figure out how long it takes the icicle to reach the sidewalk and shatter, all you need to do is plug 0 in for f of x and solve. So we have 0 equals, sorry, this is supposed to be squared, negative 16x squared plus 32. Subtract 32 on both sides. So now I have negative 32 is negative 16x squared. Divide both sides by negative 16. We get 2 equals x squared. Square root both sides. We're not going to get a whole number here because 2 is not a perfect square. So we have the square root of 2 changed to a decimal is 1.41 seconds. So that's how long it would take the icicle to reach the ground below. But that's it. That's how you use the square root method to solve both procedure and context problems.